Let's talk about how to use a cheap Amazon display to read a negative voltage. These are really great for reading positive voltages, but reading a negative voltage, like what you might use for a Fusor or an X-ray type power supply or a few other exotic projects, can be a challenge. So first I'm going to start by drawing an example of what you typically see. And it's key to note this only works with 3-wire displays, so ones that can be powered independently and they don't use the signal voltage to power and read at the same time. So here's our typical multi-segment display. The top is going to be positive, which is typically red. There's usually a signal terminal, which is typically yellow. And then there's a ground terminal, which is typically black. Along with that, we're going to have our negative power supply, which typically you will see as the positive side is attached to ground. Voltage source. So what this means is, if we draw a little plot here of Vs, as voltage gets larger, quote unquote, it actually goes more negative. So negative voltage. How do we make this work? Great question. There's two parts. Part one is you want to use something like a 9-volt battery. So I'm going to take and just draw a 9-volt battery here. What's great about this is it isolates your power source from the signal, so you can float this display. Now you can float it at a low voltage, like a couple of volts. You can also easily float it at a high voltage, for instance, negative 3000 volts, like what you might see on a microwave oven transformer. Now normally you would wire the other side of that battery to ground. And that's actually what we're still going to do here. But it's not just going to be ground, it's going to be the negative signal on the display. So as soon as you do that, this display should light up. Boom, these numbers are going to turn on. They're going to be displaying things, hopefully 0. Great. Your display would work. Now, how these displays actually work is they measure a signal from here to here. So it's this difference. And as your Y typically goes up, your voltage on your screen goes up. So if you put 5 volts on here with respect to this signal, you'll see 5 volts. How do we take advantage of that property for a negative voltage display? Easy. We're going to start by connecting the signal wire also to ground. Seems a little counterintuitive. Then what we're actually going to do next is the negative side of this power supply, you're going to connect to the negative side of your meter. So as that negative side becomes more negative from ground, this difference gets bigger. We're thinking of it as this is going more negative than this, but if you flip it around and say, well, let's pretend that this isn't moving, but this difference is growing, then this is effectively going up. The same thing that would happen if you attach this to a positive voltage source. Now here's another example where I drew out a negative high voltage supply. And we have our same setup as before with the 9-volt battery, the display, the signal grounded. And from this negative high voltage display, I also have a voltage divider. So here I have a 1 mega ohm resistor and a 10k ohm resistor, and that's a 1000 to 1 ratio. And it goes to ground. So the handy thing about something like this, as I'll show you on my microwave oven transformer, is you can set this display anywhere and it's still referenced locally to ground. So this display is only ever at a couple volts. That means it's safe to come in contact with. But it will also give you a readout in 1 volt per kilovolt from your source. Now the caveat with this type of a setup is these cheap displays do suck a little bit of current from the source that they're measuring. So a lot of times this isn't just 10K. You actually want to make this a variable potentiometer and maybe adjust it from like 8K to 12K in order to calibrate to compensate basically for the leakage current that this sucks out of your source as it measures to get it spot on accuracy wise. But you get the general idea of what we're doing. So very simple. These displays are nice. You can get them for $5 a piece. You can float them wherever. That 9-volt battery will last days powering that one display. Especially with high voltage, these types of setups can be really handy so you don't have multimeters with leads running everywhere with high voltage on the leads. You can just plop this on a table, tape it onto the side of something in cardboard, mount it in a wooden plastic enclosure, etc. And you can measure both voltage or current easily, positive or negative. The only caveat to the negative voltage examples are you need the 3 leaded supplies, not the 2 leads that you'll commonly see with just black and red, which are more designed for measuring sources like a 12-volt car battery. They measure the voltage and they power off that same power. You just need to make sure you get the 3-leg one. All right, here we have an example of a nuclear fusor, a demo one set up. And some of the examples I walked through earlier, I'm using in this exact setup. So what we have here is a high voltage power supply. And this is one of the small Amazon voltage and current meters that we saw. So zooming in, and if I pop it out, speaking of which, cardboard is a really great prototyping setup for a panel. Easy to cut holes out of with a knife. A lot of things you can drop in there. Use the actual screws you'd normally use in wood, or just tight fits or masking tape. Anyways, 3-terminal device, so black and red are power. Yellow, just as I drew on the sheet, is your signal. This can also measure current. I'm not using that. I'm choosing to use an analog gauge. It works easier in this setup. The power and ground, just like we said, hooked up to this 9-volt battery. The signal wire, we'll get a picture of it, but it's attached to a voltage divider. Sorry, the signal wire is attached to ground. The negative is attached to the voltage divider, just like we drew in the circuit example earlier. And we'll take a shot around the back of that, but simple as that. This is measuring 1 volt per 1000 kilovolts coming from the microwave oven transformer. So moving to the side here, you can see this is a 1 mega ohm resistor. Here I have approximately a 1 k ohm. It's actually, I believe, 820. And I have a 500 ohm pot in series with that. That allows me to adjust this voltage divider. And here this green wire is actually going to the ground. And this yellow wire is tied into ground, or the bottom of the voltage divider. As simple as that. Zooming back out, we can see that wonderful plasma glowing in the background. Well, hopefully you guys enjoyed this video and you learned something. Thanks for watching. Bye.